Welcome to 2015 question C-1, the geological geometry question. So we've got our accompanying map here, and it shows ground contours of 5 metre intervals. So we've got our 5 metre intervals, and it's from a hilly countryside similar to what's shown here in the image. Okay, so they want us to say that from ABC is the centre line of a proposed roadway, and GEFG is a proposed car park. So this is our roadway, and we're only going to be dealing with ABC of it, and we've got a car park just off kind of a lay-by there to the side. The roadway ABC has the following specifications. The section from A to B is level at an altitude of 65. So A is at 65 and B is at 65. Okay. The section from B to C is rising uniformly to a level of 70. So from B to C, B is at 65, C is rising then to 70. Okay, so that's going to affect what's going on out here. And then the sides of the car park are level. Okay, so side DE, so DE is level, so it's going to be at 70 there, and GF is level, so GF is going to be at that height there of 65. So this is all at 65, at 65. This is all at 70. Okay, so at 70. Okay, so using side slopes as 1:1 for cutting, so we've got a cut 1:1 and 1:1.5, so our fill is 1:1.5 for our fill. Our embankments, same thing. Complete the earthworks necessary to accommodate both roadways between A and B and the car park on the northern and eastern side. So northern side and eastern side. The earthworks on the southern side have already been completed, so we can see there we don't have to do the southern side of the road. Okay, so let's look at our cut and our fill. Alright, we have contours of 5, so our cut is 1:1. So think about our roadway here for cutting into the mountain. We're going out 5, up 5, okay? And then our fill, there's our roadway, we're filling in the side. We're going to be going out 5 metre intervals, down 5 metre intervals, so that's 5, so that's going to be 7.5, so we're going to be going out 7.5 metre intervals. Okay, so that's for our A to B. So let's see. We're at 65 here for A. Okay, and the contours are 50, 50, 55, 60. So as far as here, we're going to be filling. And then we've got heights above 65, so we're going to be cutting then from here to B. So let's start there with our we're filling. So we're going to be out 7.5 metre intervals, 65 here to begin with. So going out 65. So that's 15 and 7.5 is there. We're at 60, 65, 60, 55, so I need another one. 7.5. Okay. So we've got 60, 55, 50. So we've got there's 50, 50, 55, 60, 70. That's our first bit. And just tear that off to the side. Then we've got here to here is going to be our cut. So our cut is 5 meter intervals. So going out 1:1, so 5, 5, 5. So we're at 65, 70, 75. That's as much as we need. Yeah, there's only about that. So here at 65, 70, 75. So 65, 70, 75, 75. And back down to 65. So that is our cut. Okay, then we're level on the road here at 65, and we're going to be cutting 66. We're cutting first some of this. So filling. It's at 65. And there's, oh sorry, 60, 55, 50. Okay, so we're actually going to be filling there. So I'm going to be going out at my 7.5 meter intervals. So 7.5, 7.5, 7.5. So 65. Just extend these out, just to make sure I intersect everything that's needed. So 60, 55, 50. So 60. 55, 50, 50, 55, 60. Okay, so that's our cut, our fill going on there. Now, we know that from B to C it's sloping. Okay, so we're sloping there from B to C. So just draw a little sketch here to show what's going on. So we're at 70 here. Then B is down at 65. Okay, and we are cutting. We're filling. Yes, because it's at a height of 50, 55, 60, yeah, and it's matching up there at 70. So we're going to be filling all in here. Okay, so cut it to foot, fill it to hill. So we're going to be having our cone is going to be on this side at the top part. So got the cone kind of be on the opposite side there, but yeah, cone running around up to the top there, traveling down 5, so we're going 7.5. Okay, so we're going to be at the hill, so at the high side, and we're going 7.5 radius for our cone. Okay, so there's our cone. We're going to join it back to F. is at a height of 65. So we're going 7 or 7.5 meter intervals here now again, so we're 65. 65, 60, 55, and one more in. Okay, sliding subscribers. Okay, 65, 60, 55, 50. So 50, 55, 60, 65, and down to 70. Okay. Okay, so that is our roadworks completed there. Part A done. Right. Second part of this question then. I say that on the map, vertical boreholes at points P, Q and R reveal a top surface of a stratum of ore at altitudes of 30, 35 and 45 respectively. Okay. On the space provided on the top of the map, draw the elevation of this triangular portion, and then they want us to determine the strike and the dip. Okay, so let's draw the elevation first. So we're going up, project up our P, R, Q, R and P. Okay, and our intervals then, there are 5 unit intervals. Let's go up 5, 5, 5, 20, 25, 30, 35, 40, 45, 50. That should cover us. Okay. 25, 30, 35, 40, 45, 50. So they told us that P is at a height of 30, so P up to height 30. P. Q is at 35, so Q up to 35, and R is at a height of 45. I can draw our plane in there. Okay, and they want us to determine the strike. So strike, and just find a colour that might stand out on our pink sheet. Let's see. Right. So our strike is going to be our level line. Okay, let's project that down onto RP, down to RP, and that is our strike line back to Q. Strike. Okay, and that is a true length line, so we want to find our dip angle, so we want to see that plane as an edge view, which means we need to look out along 90 degrees to that. So project out. X1 and Y1. Okay, and heights taken from the elevation. So height of P step that here. It's P, height of Q. Off, and height of R. Okay, so R, Q, and P, and that at Q there is also a point view of our strike. This shows it's a point view of the strike. And they're asking us to find the dip angle, so that come off the page, that's going to come off the page, so I'm just going to measure the angle here. And let's measure the angle. And then my protractor. That angle I'm getting at 20 degrees. 20 degrees. My dip. Okay, so that's my strike and my dip found. Okay, now on to the final part of this question. So they are asking us, or they're saying to us that we have a lake located in the area marked L. So here's the lake in the southeast corner, so southeast corner, definitely here. The surface of the lake is at an altitude of 50. So the surface of the lake is at an altitude of 50. That means, you know, the edge of it there is at 50. Okay, so that's, even though it's not written in, it's writing 50, which makes sense, 55 down to 50. The line ST represents the center line of a overflow pipe from the lake. Okay, so when the lake gets a little bit too high, it hits S and the water flows out. The pipe travels from point S at an altitude of 50, so yeah, S is at 50, to a manhole located at T. So here's our manhole located at T, which is at a height of 40. You can see there on the 40 contour. The pipe falls uniformly at an angle of 10 degrees. So the pipe is falling there at a 10 degree angle. Determine and indicate in meters the depth of the pipe vertically below the ground at point T. Okay, so we need to create an auxiliary view of all of that looking perpendicular to the pipe. So out here, perpendicular to the pipe. Here's my X1, Y1. Y1. We'll project out T and project out S. Okay, so the height at S is 50, so let's mark off 50 there. S. The height at T is at a height of 40, isn't it? Oh, no, sorry, it's falling at an angle of 10 degrees. Sorry, so T isn't at 40. So falling at an angle of 10 degrees, so I need to measure a 10 degree angle. Just draw a little reference line for that. Okay, so sloping down at an angle of 10 degrees. That is our pipe. Okay, so now they are asking us in the question then, determine and indicate in meters the depth of the pipe. So depth of the pipe. So we're at T here. Manhole is located at T. Okay. So let's just measure vertically up. I've got T is at 32, so that's 32 meters, which would leave ground is at 40. So we're 32 meters up. Okay, that makes sense. The ground is at 40, so let's actually measure 40 here. Okay, so the pipe then is under the ground then. So determine indicating the depth of the pipe vertically below the ground at point T. Okay, so that is the height we're looking for. Okay, and it is a height of 8 meters. Okay, so 8 meters. Okay, so that was our section C, or sorry, section C geological geometry question in 2015.